Okay, so here we go. Going live. Today I'm gonna do some programming session. Yeah, so I have an idea of making an image processing scene, I don't know, library. Right? And I want to write it in Go. So let's create directory for it, right? A folder. How do we call it? Image process. Good enough, I guess, for now. Let's go. So first of all, I want to make some little research, like really. A really small one. First of all, I'm really curious, like, I had an idea of making this library in C, right? I'm not really sure if I want to, like, use C in, like, 2K25. I would probably want to use something like Zig, but also Zig just feels, I don't know, kinda raw, you know, like, kinda... The way I should just wait for it to become more adopted. But also, like, I have this, like, how can I call it? Like, belief that probably before, like, we won't meet the time when Zig is gonna blow up and become popular just because I'm just convinced AI development is gonna be faster and it's gonna, like, I don't see why would there be any other language created right now, right? It's probably gonna be mainstream language which will be used for everything. And maybe at some point there are gonna be new languages which are gonna be written with AI, right? When it's gonna be so advanced it can write like the perfect language or something like that. So I'm like genuinely don't know what to do. Also I have a dilemma if I have to process those images on CPU on GPU, right? Processing them on GPU feels more right. Okay, let's just call in image processing lib. Just check it out. Bimage. Go package of fast high-level image processing powered by libvipc library. Okay, so it uses C bindings, right? It's not pure Go. Okay. Okay, so obviously processing images on GPU just like obviously better. But also there are edge cases when you don't have GPU, right? Like on the servers. And in such situations you probably just won't like you can't access GPU, right? And I'm not sure, but sometimes you would probably want to process images. Right? And I'm not sure how long will it take. Like, if you have 8 threads, does it mean I'll need to process like pixel by pixel with those 8 threads? Does it mean like picture 1000 by 1000 will probably take like a good amount of time? There are like so many those little questions when I'm not really sure about. Collection of image processing algorithms in pure Go. Oh, so it's already done. Build a collection of parallel image processing algorithm in pure Go. The aim of this project is simplicity in use and development over absolute high performance, but most algorithms are designed to be efficient to make use of parallelisms when available. Okay. Blend, blur, channel effect. Those actually not the effects I would wanna use, right? I'm more like into, okay, brightness, contrast. Yeah, those I was thinking about. Brightness, contrast, gamma, hue, saturation. Add color. Oh, that's good. It's like overlaying, blur. This blur sucks. Gaussian blur. Yeah, okay, it's good. Damn, it was already done. I mean, I can just do it because I can, you know. Let's just look at some code. Effect. What does effect have? Oh, wait a minute. Package effect provides the functionality to manipulate images to achieve various looks. Image RGBA, okay. Grayscale. With weights, okay. Parallel. What is parallel? Whoa, now I'm curious. Line. It's actually so good. It's well done. Does it have like some benchmarks? I'm really curious. Bench. Oh, add apply benchmark. How do I? Benchmarks.txt. Let's go. Oh, how do I understand what the hell is that? Precise stance. Nanoseconds per operation. That's hell of a lot of nanoseconds. Rotation, translate. Fluid fill. Uniform color, uniform monochrome. That's something I can like understand how it works, right? What is this time? Seconds. Okay. Okay, it's actually not bad. So it's like 30 milliseconds. It's actually not that bad. Damn, do I have... Maybe it's not the problem for Go. I mean, I can just speedrun it, right? I'm gonna speedrun it. I don't care. I don't care, I'm gonna speedrun it. So what we are doing here? We create a new file. No. We are opening terminal. Fish, obviously. Clear. What we are doing here? Go. Mod init. How do I call it? Image. Like process image. IP, PI. Those are terrible names. Improc. Let it be improc, you know. Like, I'm okay with that. Now, it's gonna be a library. So what we are doing right here is touch improc.go. Then we are making directory for testing. It's gonna be cmd for command line, right? For CLI. And touch cmd CLI.go. Or do I call it like main.go? Okay, CLI is actually better. Package improc. Okay, I'm actually kind of curious about this parallel package. How does it work? Oh, it has only one function. Okay, line dispatches a parameter function into multiple routines by splitting the parameter len by the number of available CPUs and assigning the length part into each function. Alright. Right, actually I want to read this one more time. Line dispatches a parameter function, right, into multiple routines by splitting the parameter len by the number of available... Splitting the parameter len? Huh, that's interesting. So does it like provides the amount of pixels? And assigning the length part into each function. Alright, yeah, that makes sense. Okay, let me see it. I want to see it one more time. Effect. SRC-H. Oh, source with source height. Source height. Whoa. What did I start and... Okay, I'm so confused right now. What is start and end? What the hell is start and end? Oh, I probably have to say it here. Parallel? Parallel.go. Oh, can I? Is there like examples in parallel test.go? Line. Len. Func. Okay, never mind. Len. Start and each function. What is start and what is end? Start counter minus part size. Damn, that's so difficult. Actually, I feel like I don't really need it. I mean, I probably can invent it myself. That would be, I don't know, easier, better. I will learn something. Let's start from the very base. First of all, I have to import image image package from the golang. Import image do image do Go has image package. Golang image package. Let's see it. Image package, let's go. Is it like, oh, it's not like in standard library, right? It's a go x. It's big, it's not something I want. Package image implements a basic 2D image library. Oh, wait a minute. But how do I present it? Example. Package image JPEG is not used explicitly in the code below, but it's imported for its initialization side effect, which allows image code to understand JPEG format image and commands these two lines to also. Okay. But how do I use it? Do I have like image? So it's a standard library. Do I have like fmain? Yeah, I have how is it called? LSP. Right? Import. Oh, actually I want to make it bigger for the stream. Image. It doesn't work, what the hell? Go, get image. Am I missing something? Come on. Go add, I don't know. Add. Go help. Go package. List image. Okay, I have one. Okay, fmain. What am I doing here? OS open, right? Reader error. OS.open. I don't know. Image.png. What the hell have I done? If error not equal new. Oops, what have I done? New. Panic. No, not panic. Log.printf. Oh, it's like fprintf because it's fatal. Fprint. Fatal. Is it fatal? No, it's not. Print. fmt.fprint. Okay, log.print. Printf. You know, I'll just panic, I guess. Panic. How do I golang log crash with report? Those are like really unrelated. Okay. Okay, what I'm gonna do now is to ask... I don't really need thinking. How do I use log package in golang to stop everything and print the log? Log fatal. It's log fatal. Fatal F. Oh, it's fatal F. It's fatal F. Fatal format. Yeah, it's fatal F. Okay. Error. Reading file. Opening, I guess. Opening file. We got a reader. Alright. He decodes it. Why is it commanded? Because it's JPEG if reading from file create a reader with. Okay. Oh yeah, I have to close it actually. Defer reader. Dot close. Nice. Base64 decoder. Why? It's then encoded strings new reader data. Interesting. Okay. Wait, you... Oh, yeah, I already have files, so I don't really care about it. Data. Where is the data coming from? Is it like just invented? Image decode. Oh. It's so simple. What is the second volume? Curious. Image. Here we go, decode. Reader. Oh, reader. What is the second volume? Declare not used string. Let's read. The code decodes an image that has been encoded in registered format. The string returned is the format name used during format registration. Interesting. So it's like a file extension, right? So it's like JPEG, PNG. Format registration is typically done by an int function in the... What the hell is... String. Fname. Huh? Format. What the hell is format? How do I sniff? Format. Name, magic, okay. Magic number, decode. Format holds an image format's name. Okay. So it's like JPEG, PNG. What is M? Is it like matrix? Bounce and bounce. That's good. Okay, I want it. I want to check error. Actually, golang error check can drive me nuts. I have only 2 of them, but I already tried. Okay, it's anyway better than JavaScript, so I don't have to cry. Bounce. I have to make bounce. Bounce equals image. No, not image. M.bounce. What is M? M is matrix, right? It's matrix. How is it called here? M. Fascinating. Decode. Image. So it returns image. Okay. Can I like call it img? Img. Bounce. Declare and not use bounce. I don't care. What is image rectangle? Good. What am I doing next? Guys 16 been histogram for unthread. What's gonna be the simplest thing I can do with the image? I can rotate it, right? Is it gonna be simple? Probably not. Like, I have no idea. Okay, I have an idea how can I rotate it in place, right? Is it like I'm really bad at math, but is it like matrix inversion? So I just take diagonal and I just swap the pixels. Or will it mirror it? It should just rotate it, isn't it? Like, if we're taking some, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? If we're swapping like 9, 1, 6, 2, 8, 4. Yeah, and now it goes like 1, 2, 3, 4, 5, 6, 7, 8, 9. How did we rotate it? So it was... This one was... So now it go... wait a minute. How can you... So I rotated it like 270 degrees, right? Minus 90. No, wait. Was 1 here. We rotated counterclockwise, right? So 1 is here, 2 is here, 3 is here. Oh, it's not gonna be. It doesn't rotate it. I was wrong. That's not how it works. Okay, so there should be a way to rotate it in place. So the only way to make it in place is to swap numbers, swap pixels. Rotate matrix in place. First, transpose the matrix, swap rows and columns, and then reverse each row. Okay, so I guess I was close. If I know what transpose means. 1, 2, 3. Okay, he did it on the other diagonal. Yeah, he did it on the other diagonal. Reverse the columns of the transposed matrix. Oh, that makes sense. Yeah, so now those are on the bottom, so you're like, yeah. Actually, it should be good. I mean, it will take memory. Oh, it won't take memory, but will it be faster than just creating another image? Oh, actually, it will be if we are gonna like make real-time image processing, like for instance with a sidebar, right? That way, if we want to make it like live editing, it's gonna create new image every time, and it will have to call the operation system to get the memory, which is gonna be slow. So I guess this approach should be the fastest one. So what we are doing here, rotate image, right? Func. Do I have it in golang? I'm actually kind of curious. Image. What do we have here? Alpha, black, error, format, decode, image. Do I have something on the image? Image dot add bounds color model bound. Actually, we have nothing here. Image. New alpha. Point, opaque, rect. Yeah, there's nothing here. It's good, it's good. That image. How do I call it? Rotate clockwise. So it's gonna be always 90 degrees, and I think it should be obvious, right? How else could you? Oh, wait a minute. We can rotate it in place only if it's a square. That sucks. This actually sucks. What are we gonna do with that? I mean, we can use dynamic race. Is it like, what is image? I'm curious. Image. Image is an interface, but what image really is? I'm curious. Okay, RGBA 64. Huh? Wait. It's like not an image. Should be an array. Image. It's an interface. Image. RGBA. Okay. RGBA is in memory. No. RGBA is an in-memory image whose add method returns color RGBA values. Pix holds image pixels in RGBA order. The pixel at XY starts at... What the hell is that mess? That's interesting. So it's a one-dimensional array. Oh, that should be possible, right? They use one-dimensional array. Actually, I feel like all those abstractions that just make it worse. Like, it's cool that you can treat everything in the same way, but it's gonna... I feel like it's gonna impact the performance. Should I care about that? Probably not. Like really. Not to that level. Okay. Can I modify image? How do I do that? Image. Can I should always create new image, really? Wait a minute. It should be okay, let's check it out. What does this man like what does this man do? Invert. Interesting. Image. Adjust apply src. Fan apply. How does apply work? That's a good function, by the way. Apply. Image bounce. Image bounce. Destination. Clone as RGBA. That's some black magic happening right here. Wait a minute. Bounce the dx, bounce the dy. Parallel line. Okay. Wait a minute. Return destination. Oh, so it clone sRGBA. What the hell is that? sRGBA returns an RGBA copy of the supplied image, so it creates copy every time. Yeah, it creates copy every time. I don't really like it. What do I do about that? Don't use like built-in image package. I don't like this approach. Image RGB. Draw image bounce mean. Draw src. Yeah. Turn image. That's unfortunate. Because it means it's always gonna be new image. And I can just make it in place. You know what also does it mean? That's a good reason to learn how to decode images. How to decode PNG, you know? Probably PNG is not gonna be the best one, it's like optimized format. There should be better ways. Like there are how's it called? I don't really know, like image, like which is basically bitmap, right? Where you have an array of pixels. Most raw image format. Bitmap, I don't know. BMP, it's called BMP. BMP. DNG viewer is a free, okay. Raw image supports some BMP. The BMP file format or bitmap is a raster graphic image file format used to store bitmap digital images independently of the display device, such as graphics adapter, special Microsoft Windows, and why is special Microsoft? Are they like a free standard, or is it free standard it's just called a special Microsoft Windows? The BMP file format is capable of storing two-dimensional digital images in various color depths, and optionally with data compression, alpha channels, and color profiles. Developed by Microsoft. Image, no compression. Image format. BMP, PNG, TIFF, and RAW. These formats are ideal for professional photography. Okay. Actually, why am I like using Google? Like really? I want to learn image decoding, and I want to start with the simplest thing possible. Which image format? Which open image format is basically an array is the simplest to decode. Let's go. Oh, it syncs. BMP, so yeah, it's BMP. The simplest widely recognized open image format to decode manually is bitmap, specifically and compressed 24-bit. Yeah, so it's like 3 pixels with 8-bit or 32-bit bitmap because it's also alpha, right? Here's why. Minimal structure. A standard BMP file has a relatively simple header section, a file header and an info header. That tells you the image dimensions, color depth, and where the pixel data starts. No compression. In the simplest variant, the 24-bit and 32-bit uncompressed BMP formats store pixel data directly, row by row. Nice. With no compression applied. This means the bytes you read directly correspond to the color values of the pixel. Nice. Direct pixel mapping for uncompressed. Every 3 bytes in the pixel represent 1 pixel, often blue. For 32-bit, it's typically 4 bytes per pixel. There is no complex decoding step like Halfman. Okay. So we'll start with why other formats are not simple. JPEG is difficult, as far as I know. Highly complex, lossy compression, yeah. Quantization, Huffman, arithmetic coding, you need to understand frequency domains, and entropy coding. That's actually so interesting. I want to decode JPEG, I really want to do it. PNG uses lossless compression, deflate, which is... I actually heard about this one. Zleep, yeah, that's probably the reason why I hear it, and Huffman. Also has filtering and chunk-based structure. That also, like, doesn't JPEG also has chunk-based structure? So you can, like, it takes an array of pixels of the same color and marks them as like, makes a shortcut of them, you know, like a loop. Requires implementing using a deflate decompressor. Okay, GIF. Uses LZW compression and has block-based structure plus handless palettes and animation. Requires understanding LZW. I have no idea what is LZW. Very flexible, TIFF. Very flexible and complex. Supports various compression schemes and attack-based structure. Okay, so we're starting with BMP, but first of all I want to drink some water. I'll be back soon. Okay, so here we go once again. Bitmap, BMP. How do I decode BMP? How do I decode BMP? Let's go. I don't want it to sing, brother. Please don't think. Also, I'm really sorry about that. Also, I really want to try a new DeepSeeker one. Also, just because it's open source, I want to support open source, that's why I would probably use DeepSeeker one. It's in existing libraries. Recommended. No! I guess that's because it doesn't know that I want to learn it. How do I decode BMP? Let's check it out. Core steps. Understand the structure. BMP files have a standard header structure. You need to know the layout and size of the bitmap file header and bitmap info header, or their modern counterparts. Open and read file. Open the BMP file in binary mode. Read BMP file header. Read the first 14 bytes of the file into structure of variables that make the file header layout. Can you tell me what layout is, or is it gonna be next? Validate the file header. Read. Extract image information from the info header. Get between the width of image and pixels. How do I do that? Can you tell me? Can you don't provide me the code? Why treat me like a child? Open router. Okay, so I'm opening openrouter.ai. I want to use R1, right? What do I want it? I'm actually really curious about distilled Quen 8B, because I heard it's like for its size, it's so good. I'm really curious. Is it really that good? It's also really cheap. How expensive is R1? I mean, it's not that expensive, but still a lot more expensive than a Quen 3 8B. Oh, it's free by DeepSeek. No. It's the model. It's Chatters, right? But Chatters have some really low quality compression, as far as I know. How is it called? Quantization. Oh, only one provider? Okay. Chat. Let's check it out. I'm learning image decoding. Learning image decoding, and I want you to, what do I want it? To explain to me how to decode BMP images. Tell me about its layout. How is it called? Byte layout? Bit layout? Byte layout. Do not give me ready to use solutions. Just give me info. Like raw info, so I can learn from it. I feel like this prompt is so bad, but it's alright. Damn, actually this sync is so slow. The file header. Typically BMP is in BIMP's own order. Actually BMP is simple format and many parts are fixed. 2 bytes signature. It's always BM. Okay. File size in bytes. Wait. Seriously? In a way. Wait. Oh, it's bytes. Oh, so it's gonna be that way, right? Yeah, that makes sense. Okay. Actually, I don't want to use R1 anymore because it syncs so long. Maybe I should just use Quen, without syncing. I can disable syncing there. What is the strongest not syncing model? LiveBench? How's it called? LiveBench, right? O3 syncing, Claude syncing, syncing. Then they are all syncing. Okay, Claude for Opus, it's expensive. R1 is syncing. Quen 3. Okay, so Quen 3 is the best on syncing model. On par with Flash. Is an average? Coding average. Agentic code average. But what about like general knowledge? I don't know. It still syncs. Ain't no way. It still syncs. Maybe I should just continue using Flash. I don't know. Do not. Let's. How's it called? I forgot every word I wanted to say. Shout at him. Do not. Okay, I don't want to shout. Do not provide. Act as a professional teacher. Professional teacher. your task is to make should I call myself use, or how does it work? Your answers should be goal is to make answers which will teach about concepts and not provide ready to use solutions. Okay, I guess for now it's good enough. I'm learning image decoding and I want to start with BMP. Where should I start? It's syncing. Okay, no, whatever. At least it syncs fast. To decode BMP images, here's breakdown of the file format structure and key components. File header, BF type. Okay. File size in bytes, unused, usually 0, unused. BF reserved, interesting. Of bytes, offset to where pixel data starts, typically 54 bytes for standard, interesting. Okay, that's a fantastic choice for starting BMP. It's one of the simplest image formats, making it perfect for learning fundamental concepts. My goal here is to teach you how to approach decoding BMP, focusing on the concepts you need to understand. I won't give you ready-made code, but I'll guide you on what steps to take and what structures to look for. The core idea, file structure. Every file format, especially... It treats me like a child. I have to mention that I'm not a child. Where to start? Understand this BMP header. Here's the main section you encounter. BMP file header. Damn, like, this is so much better. Let's just code it. So what we are doing right here. It's gonna be another library, but I will write it right here. Func decode BMP for now. What do I take? Reader? OS.file? No, I'm taking reader. Yeah, IO reader. So it's like R, IO reader. Image decode, interesting. Does it? How does it know that? Oh, because image extension is like in there. Decode BMP, what will it return? Image.image. Do I have to create struct RGBA? Do I always... Does BMP support BMP alpha channel? Can BMP image handle transparency? Yes, a bitmap. Format does support transparency. It depends on the compression method. The default RGB method supports, but bit fields compression supports. You can read more. I feel like I'm doing so lot of unnecessary jumps, reading, looking. Like I feel like I have just do more. Okay, let's start simple. Let's not add alpha channel. So it's gonna be 24 bits. RGB.R, is it gonna be good? Int 8. Let's just repeat it. Blue. Expected name, RGB expected. What the hell do you mean? Oh. Eh? Oh, it's not how it works. Type. RGB struct. Yep, here we go. Type image, and it's gonna be body, just an array of RGBs. That would make sense. Right? That makes sense. Struct. Also, I have to keep width and height, just so we can make operations on it. Wouldn't it be better? Wouldn't it be better to make a two-dimensional array? It's not gonna be a matrix, right? Like native matrix. It's gonna be array list anyway. But if I allocate it, can I allocate it continuously? At what the point then it's gonna be indexed the same way if I was indexing it like by myself, right? Yeah, that's interesting. Yeah, probably that's the best approach. Okay. Decode BMP. And I return image. Here we go. Why is it here? Wait a minute. Okay. I really liked R1 Quench rate view answer. Device identifies file as BMP. So I just skip them. Oh, I can provide error if it's not BMP, right? Error. Error.read. How do I... What methods do I have here? Reader. Can I? Wait a minute. What's wrong? Okay, now it works. Error.read. What it does? It just... like... Reader is the interface that wraps the basic read method. Are you reader? Or read reads up to len p. Oh, okay. Bytes into p. Okay. It returns the number of bytes read and any error encountered. Even if read returns n less than len of p, it may use all of p as scratch space during the code. That's so... What does a scratch space mean? If some data is available but not len p bytes, read conventionally returns what is available instead of waiting for more. Okay. When read counters an error, end of file condition after successful reading, it returns the number of bytes read. Let's just make it work, you know. Bytes read, I don't know. Can I buffer clone compare contains? I will make my function func read n bytes. RIO reader. It's gonna be... Oh, it's interface. I don't have to make a pointer to interface, right? Reader. Array of bytes. Oh, I also need len int byte var like bytes. Oh, it's gonna be a package b make byte with len. No, it's actually gonna be 0 and len. And then read b. Return b. Read n bytes r2. Will it? Oh, it can return an error. I hate it. Can I do anything about it? Probably not. Error. Return b error. Error. And okay, it becomes complicated really quick. And okay, still feels better. Int. Is it int? It's int. And red. Oh, it's not gonna be red, it's gonna be read. It's gonna be counter. Read counter. Just so I can know for sure it's gonna be 0. Then I'm going like n. What is next? Is it like the correct order? N error. Oh, because it doesn't return bytes. But I want to return bytes. I'm gonna do it first. Then error, because error is always the second value. Or is it? No, it's always the last value. It's always the last value. It makes sense. Okay. How is it called? Hello, Sakura. Hello, hello. How are you doing? Well, I love hardening yourself. What do you mean? Okay. How is it called? It's called BF type. With parallel. Okay, maybe I'm masochist. I mean, it's interesting, isn't it? Decoding images. Like, from the very beginning, I wanted to use image package. Okay, so there's gonna be a lot to tell you. First of all, I'm making image processing library in golang, right? I was planning to use built-in image package, which basically allows you to parse images, right? So you can just get the image in a ready-to-use format. Are you making it for website? No, it's not. I'm just making it for fun. And to fill portfolio. Like, I thought a lot about it on the beginning of the stream. I also was thinking about making it in C, but C feels really old. I was thinking about making it in Zig, but Zig feels really raw. But then I also was thinking about making it on CPU or GPU. Like, obviously this kind of task is better to do on GPU, but also it could be like I can take a niche of something like servers where you don't have GPU and you can process them on the CPUs, and Golang concurrency makes it so much easier. Why all this bad? Not all this bad, like C just aged bad. I don't say like all this bad. Actually, I would even say C is still one of the greatest language. Like I would actually prefer C to a lot of languages. Like I would prefer C to JavaScript, obviously. But after using something like Golang, it just feels bad. It's really aged bad. Like don't have Boolean as a native type just feels ridiculous. And this is one of the least problems of C. The biggest problem is its how's it called? Macroses. Is it called macroses or like macros is already plural? I believe macros is already plural, right? So macros are great as a concept, but serialization realization of them is just so bad because like you can't, LSP doesn't work with them. Like basically macros, you just can't understand them. They are not readable. People, like all the C code is pretty much like 80% macros and you just can't read it. You don't need it anyway. Bool is for pussies. That's true. Or maybe that's one. That's the one. I would say that's one. Okay. So here we go. Now I'm doing some. I decided, you know, like I'm making such a big problem out of nothing. Why wouldn't I just like learn things, right? I would just write everything in Golang and just learn things. Plus, I like Golang. Plus, after I write it once, I probably will be able to port it. Plus, I'm doing it like I'm pretty sure in almost any language there is a library, a package that allows you to do the same thing I'm doing right now. So I decided to be like just a part of portfolio and a fun experience. So I'm making it in Golang. I plan to use standard image package to process the images, like to get the format in which I can process them. But it's so generic, like it has such a huge level of abstractions that image is an interface. What does it mean? That means I can't like directly access the image, I can't touch it, I can only read it, right? What does it mean? If I can only read it, every time I change the image, I have to duplicate it. So I have to make another copy, which is gonna be modified. And then if I want to modify this copy, I'll have to make it copy one more time, and it's gonna be really bad, I feel like. It's gonna take a lot of time. So I'm doing, like, I decided to don't use it, right? And I will decode images myself. This also is additional fun because I never decoded images. And I feel like it should be a cool challenge. Like, for instance, where it was? It was... Wait a minute. Here it was a great description. So like, right now I'm decoding BMPs, which skillishly sounds simul. What do you mean simul? Where is it? I can't find it. Okay, so the point is I'm doing BMPs, which are just basically metrics without compression. You just read byte by byte, and that's an image. But then there are gonna be PNG, JPEG, which has complicated algorithms, which I'm gonna learn. And it's gonna be interesting experience. Image decode image sounds simple. How can I tell you that? Okay, BMP is gonna be pretty much simple, right? Wow, I have so many tabs opened. First of all, I have to read header. It's BF type. So we have BF type, then we have n, and then we have error, and then like read counter plus equal n, then if error not equal nil, return error, nil error. What is image? Oh, it's struct, so I'm returning empty struct image. Do I have to return? I should probably return pointer. Or should I? It's gonna be garbage collected. If I'm returning pointer, it's gonna be garbage collected. But also it's not gonna be copied. Images are big, and copying them is not good. It should be pointer. It should be pointer. Nil. Oh, we are returning nil pointer. Let's go. Error. BF type. If BF type. How do I compare bytes? Bytes. Same? I don't know. What do I have here? Clone compare. Oh, let's go. BF type. Bytes. How is it called? Oh, it's BM. And should return false if it's like not equal. Huh? Non-boolean condition in if statement. It's int. Compare returns an integer comparing to byte slices lexicographically. The result will be 0 if a equals b, minus 1 if a less than b. Oh, equals 0. Not equal 0. Byte. Return nil. Errors. error.new. Error. No, it's not how. Is it like fmt.rf? Yeah. Actually, I have to make it better, but okay, it's good for now. Good for now. Bf type does not equal bm. I feel like I don't need it here right now. Okay, we get half job done. Bf size, file size in bytes. What does it mean, file size? Huh? File size? It's not we, it's not hate, but file size. Like, why would I have file size in bytes in the file? Whatever, I can just keep it. Read. Do I like make byte? How many bytes is here? 2. Then it's gonna be 2, 3, 4, 5. It's gonna be 4 bytes. 4. And error. And it's gonna be so tedious. Okay, it works. Does it? Yeah, it does. Nice. Going next. Yeah, maybe I should probably not use Go. I don't know. I feel bad using Go. Like, it's ugly. It's so ugly. Like, I will need to do that every single time. What do you think, Sakura? What should I use? Don't tell C++, please. I beg you, don't tell C++. Okay, I'll just proceed, hoping for the better. File size in bytes, I got it. I don't store it, but who cares? Then I have reserved. It's gonna be 2 more reads. More if error not equal nil. I can't help it. Like, really, I was thinking if I can, like, I don't know, wrap it in function or do anything. I just can't do anything about it because I will have to, like, move it upstream anyway. Like, really. Those moments I, like, really regret I'm not running Rust. Is it too late to jump on Zeek? But also it won't help my portfolio, right? I really want to build my portfolio. Okay, just I just have to focus. I just have to take it as it is. 6, 7, oh, it's 2 bytes. 8, 9, it's another 2 bytes. 2. Okay. BF of bits offset to where pixel data starts. Typically 54 bytes for standard BP files. Why? Image header. Oh, okay, so what is that? Bitmap file header. Bitmap info header. Okay. Wait a minute. Does it mean it's not always 40 bytes? If it has an offset. Like, it means that there should be dynamic size between image and this offset. Okay. This function is the code BMP, so I'm doing everything here. Let's go. I want to store... I want to make this one. And it's gonna be... what's it called? BF of bits. BF. Do I have to call it BF? Is it like it's bitmap by... oh, file header, info header. Okay, file info. That's why it's BF. BF of bits. It's 4 bytes. 10, 11, 12, 13. 4. Okay. I don't know, I wanna cry. Like this syntax, it just kills me. I just can't watch it. Like it looks so bad. This read counter plus equal n if error not equal nil, it just repeats all the time. Okay, I'm keeping myself like calm and just proceeding with writing code. Image header. Header size, usually 40 bytes. What's the point of making offset and then making header size? Isn't like offset determines header size? It's so weird. Like that way you don't need offset. 12 pixel data starts, typically 54 bytes for standard BMP files. Okay, let's just continue. B size. And error. I'll just copy it. Can you wrap that extracting with loop just save all in array? I mean, it won't make it better, I feel like. Wait a minute, I'll have to think about it. Besides, can you wrap that extracting with loop just save all in array? I don't clearly see what you mean, like really. I hate myself. Oh, it's so bad. Okay, it's good now. I have an idea. I can make, I'm not sure if it's a good idea because it's probably gonna make debugging harder. Like, I can make only, like, don't check if error not equal nil only at the very end, right? So, I'll just always, oh no, it's not gonna work. I have to check if error is not nil and only then save it. It's not gonna work. You always read and check if nil. Yeah, you mean like make an array of errors and then check all of them. Do you think it just feels not idiomatic, you know? It's like, so is a loop with it or loop? Okay, let's just, like, I want to ask AI. Because I feel like it's bad. I can't tell why, but I never saw that. It's less code. Yeah, but it's not always better. Like, if we are talking about C, in C, less code, it's always not better. Like, most C code prefers more code, but cleaner code. I can't tell why, but I feel like it's bad practice. Is it good practice to store a huge amount of errors in array and check them how do I write simultaneously? Simultaneously. Okay. Oh, it can understand me. Simultaneously. Simultaneously. What is simultaneously? Loop is cleaner. You're probably right. I feel like that's something I'm gonna do. I just wanna check it out. I don't mean store array, I meant store all other. Wait a minute. You always read and check if nil, right? So is a loop with it or loop with functions that read? It's less code. Loop is cleaner. I did mean store array. I meant store all others. So I don't understand. Like storing errors is the only way. What else can I do? Make it in a loop. It's gonna if like I'm correct to understand what you wanna do, it's gonna complicate things a lot just because the loop will have to take generic function, call it, take error, it's gonna store, it's not gonna work. You have loop that reads, stores what read, and check for new. Those actions are not repeated, like they are different. I store different values here. That's the point. I can do that in a loop. I mean, I probably there should be a way, but it's gonna be so unreadable, you don't want to do that. It's much better this way. I'm curious about making an array of errors. That feels like a good compromise. In array and check them at the end instead of checking one at the time in golang. Let's see. You just don't know how to do it, but you can. Be more creative. Do as I say. I'm trying really hard to generate some answer to that, but I just can't. My brain refuses to brain that way. Like, my brain is not braining anymore. Why handle immediately approach is preferred? Okay, generally no, it's not idiomatic Go practice for most situations to store a huge amount of errors in an array and check them at the end. The idiomatic Go way is to handle errors immediately when they occur. Yep. Fail fast. You detect, yeah, that's a good reason. You detect and handle problems as soon as they arise. Yeah, this prevents the program from continuing in an invalid state or performing fuse operations that might also fail or produce incorrect results. Yeah. Clear error origin. When an error is returned immediately, it's easy to trace back where it's originated. The stack trace, if applicable, will be more, yeah. Simpler control flow, yeah. Resource management. If an operation acquires sources, files, network connections, immediate error handling allows for proper cleanup. Interesting. So I can't. Like, I just can't. I mean, I can, but I don't want to do it. Okay, I have a better way. Okay, so is there to join? Interesting. Is there a way to escape all the boilerplate in the following code? Go. Red update button. Yeah, I see it. What's wrong? I saw it like from the very morning. Does it trigger you? Do you want to click it? No. Okay. Just saying. Okay. I mean, I can see it. I just don't really care about updating right now. Yes, absolutely. The code you've shown is a prime candidate for refactoring. Okay. Return bytes. It returns error. It actually made a good assumption of what am I doing here. Oh, wait. IO read full ensures all n bytes are read or returns error. I feel like I created a necessary function. No, this formatting is so bad. Read bytes, skip bytes. Oh! So it created struct. No, wait a minute. BMP decoder, yeah. Skip bytes, yeah. It actually makes sense. Yes, my architecture from the very beginning was not suitable for that. I'm kind of tired. I'm gonna like create this struct, add some methods, and enter that for today. Struct BMP decoder. What is gonna be here? How does it, like, is it like pointer? It's just a like pointer where am I in an array? BMP decoder, IO reader, read counter, error, Byte order. Wait, how does it check for error? Read bytes. Error returns the first error encountered during the coding on new, but it will continue. It will continue proceeding, isn't it? Like as in previous. That's so interesting. Like code architecture is like generally so interesting topic. Error, are you a reader? And do I have to call it N? No, I don't. Counter. Is it like red? I can't, like, I hate it so much. Why does red write the same way as read? Like every time I see it, I just want to read it as read, but it's red. Or am I like overcomplicating things? Everyone can read it as red. Int. Counter. Right red. You mean right red? It's not that red what I'm talking about. It's not like red color, but read in a past. Like not. It's not past. It's red amount. It's noun, right? Red is noun in this context. It was red. It doesn't really care. Red. You write it how it sounds, red. It's not how English works. Error, red. What else? Error. What else was there? Byte order. Binary. Typically little endian for BMP. Binary byte order. What the hell is binary byte order? Binary byte order. It's an interface. Byte order specifies how to convert byte slices into 1632 or 64-bit unsigned integers. It is implemented by little endian, big endian, and native endian. English should make new grammar. I mean, if only it was that easy. Let's be honest, English is not that bad. It's like C from the spoken languages. Like it's C from the programming languages. I'll just update it. Oh yeah, I see now. Yeah, how couldn't I come up with it? I don't really understand what byte order is. I can just ask. Does it have? What does byte order do? Let's see. English is not C. Not in English is not good. It's good enough, just like SC is. It's universal, just like SC is. It's like single most popular standards, just as C is. English is. I already read it. Byte order, also known as endians, refer to the order in which bytes, the individual 8-bit units of data, are arranged in computer memory. Okay. There are two primary types of byte order, big endian. Does it like return just... I don't get it. Wait a minute. Where it was? Oh, it was here. It was right here. Binary byte order, typically little endian on BMP. What is this interface? I'm so confused. Beacon is the most significant byte of the data is placed at the lowest memory address. Okay, I understand, but what's the point of this in my struct? Think of it like, okay, yeah. It's then. Why does bit order matter? Data interchange, file formats. Many binary file formats like images, executables, RQ specify a particular byte order for the network protocols. Okay, how Go's encoding binary package helps. In Go provides tool to convert multi-byte number between their in-memory. Oh, no wait. I still don't understand it. Wait, there were like put you in 16. I still know him. I'm pussy. I guess that's the most reasonable answer I can give you. I mean, at some point I'll get to it. Why does byte order matter? Yeah, I know that. BMP decoder, typically little endian for BMP. New BMP decoder, binary little endian. BMP are typically okay. Little endian. Returns the int 16 representation of b from 0 to 2. Bound check. Is this like just converts it to a number? Oh yeah, it just takes number. Yeah, it just takes bytes. Okay, I see now. Byte order, yep. Binary. Do I really need it? Little endian is beta mentally. Why are you so mean to little endian? Okay, I'm curious. Little endian with big endian. Is there like a clear reason which one is better? As far as I know, there's just like different problems which are better with one endian or other endians. Is there like a quick comparison? And there's that endians determines the order in which bytes. Big endian stores the most significant bytes first. Yeah, well, little, okay. Which is better? Little endian is dominant. Go big for off. Little endian is dominant in modern computing due to its simplicity and common use with Intel and ARM processors, while big endian is preferred for network communication. Yep. So it just happened to be that way, am I right? It just happened to be that way. There's like no advantage. Let's say you have a 32-bit integer equal to 1. And it's at offset, okay, so looking with hex viewer, yep, you just look at 1 byte and you know what it is. It can be Boolean. Boolean values are wide for a reason. The reason is word alignment and cache. Yep. So basically you need just a bit or a few bits, but you can access them quicker when they align by words. But won't it work the same way with big endian? However, the address is just direct. You don't have to add an offset to your offset or do additional bit shifting to get the value. Let's say you have big endian, so you have, yeah, makes sense. So your value packed to a byte would be, oh, so I have offset to offset. But like, isn't it can be like made a hardware feature that costs nothing? Plus you would have to modify the offset and migrate into 60. Yeah, actually the endian is better. You can, if you know the LAN, right, you can just, you don't have to go from the back, yeah. Practicing NDS doesn't matter that much anyway, it only matters for the requirement you must. Okay. Order. It's called order. Byte order. Actually, I'm pretty tired. I'm gonna stop it here. And I'll proceed with it tomorrow. Or maybe, just maybe, I don't, how can I say it? Don't promise you, right? I don't promise you. But just maybe tomorrow I'll install Vim on the stream and configure it. Oh, wait a minute, I already have it installed, it just doesn't work. I forgot about it. Rusty. I do like nvim. Nice, so I quit cd me go image process and vim here. And so I'm opening .go file and I got this. Yeah, that's what I got. Meson errors, and I can work without Meson because it's basically LSP. It highlights everything. Okay, highlighting does work, and I got errors. Wait a minute, it does work. Why do I have those errors then? Do I have snippets if main? I have snippets. Wait a minute. So what are those errors? I don't really get it. Quit all. One more time. Fail to install bash ls. Astor animals. There is no go, that's the point, yeah? Instance fail tailwind. Okay, whatever, it seems like it works for go, right? Good thing to know. And thank you for coming, Sakura. It was really great team. Yeah, see ya.